There are occasions when the definition of the derivative will be reversed and you will be asked for specific information from the derivative, and the information that you'll be asked for is what is the a value, meaning what are you plugging in for x, or what is the function itself, so you can turn around and take the derivative. So this will come up later. So I'm going to show you two examples of how this can be done. This is our traditional definition of the derivative, where it would say the limit as h approaches 0 of f of x plus h minus f of x all over h. But in this case, instead of x, you actually have a number there, meaning what you're going to evaluate the derivative at. And here, this is an even more simplistic variation of that, where you have the limit as x approaches a, but essentially this is the equation or the function for the slope of the secant line. So I'll show you the pink first and how we identify it. But one thing that you do need to make note of is that instead of h, sometimes you can also have delta x, because what h represents is the difference between the two x values on the x-axis and the distance that you want to reduce down to 0. So if you take a look at a couple of our examples here, some of the specific things that you'd be looking for is if you have h approaching 0. So here we have h approaching 0, here h is approaching 0. Our substitution for h, which is delta x, is approaching 0, and then the same thing down here in e. Okay, so how do we use this? So in this case, we have as h is approaching 0, so that means I'm using the first definition, and this 4 plus h right here, or this 5 plus h here, because these are the same variation, this right here is my x value. Okay, so this would be replaced with x. Okay, so what we're saying is here we're using definition number 1. This is my x, so this is technically my function. Okay, so my function here, f of x, is I'm going to take the 4 plus h out, and I put an x in there, and I'm left with x squared. So what we're saying is that our a value is this. If you go back up here and look, it's 4. What's 4 squared? It's 16. So then here we're saying that this is my x. So we're saying the function here is 2 times x cubed. So our a value is 5. So if I were to say, okay, 2 times 5 cubed, I would have that value, whatever it is. So I'm using definition number 1 here. And what they're saying is find the derivative, because this is a definition of the derivative, at 4, or find the derivative at 5. Then, on the other hand, here, this is a more simple, this is definition number 2, but the way that I would know that is it has the limit as x is approaching some given a value, and the a values are all going to be the same. So if you take a look at these other two examples that I didn't highlight yet, here you have x is approaching 2 or x is approaching 3. So when I take a look, f of x, this is my actual function. This is f of x right here. So it's given to you. So in this case, f of x down here is 2 over x. This is definition 2. Here f of x is equal to x squared. Okay, so now to identify my a value, go back up here. You have your a value in 3 different places. You have your a value here, here, and here. This is probably the most obvious. So my a value is 2. My a value is 3. And this is definition 2. Okay, this will come in handy later on.